So, what are polymers and where can they be found? Polymers are absolutely everywhere. They form the materials in your bottles. They're the fibres in your clothes. They're even naturally occurring inside you. They're large molecules made up of small units linked together called monomers. The monomers are added to a growing polymer chain one by one, a bit like threading beads on a string. You see, the structure of polymers and their individual monomers affects their physical and chemical properties. In fact, there's an entire chemical industry dedicated to focusing on the creation of specialist polymers. These specialist polymers are designed so they are the most efficient for their specific purpose. When it comes to creating polymers that are cheaper, more efficient, and better for the environment, we need to be able to change properties like solubility, strength, and degradability. At Sydney Water, to help us separate water and solids, we use specific polymers called flocculants. Flocculants are great, and they work by sticking very small particles together and making them big enough to remove from the water. But for polymers to work in water, we need them to have good solubility. As water moves around, they need to be strong and hold together, but not too strong that they clog our machinery. One such flocculant is made of acrylamides. When we take a look at the functional groups of acrylamide, we can see that there is a polar and a non-polar group. The monomer, acrylamide, can float around in the water, attached to solid particles, but can't help us separate the solids from the water. We need to use its additional polymer, polyacrylamide. Polyacrylamide has the same polar and non-polar groups, but because it's a long strand, it can attach to more solids in the water and each other. If we want to change conditions or target certain particles, we can further manipulate polyacrylamide. When we add on other monomers, it's called a copolymer. This gives us the opportunity to make the polymer weaker or stronger, charged or uncharged. When these polymers stick solids together, they make it easier for us to capture and separate them from the water. The polymer is trapped in the solids and removed. It's important at Sydney Water we consider the design of polymers and how they behave. We want polymers that degrade safely in the environment and allow us to reuse these solids for things like fertiliser. These polymers also help us clean the water, so we can reuse it and protect the environment.